Hi everyone, today we're going to take what we know about linear equations. So we have graphed linear equations, we have solved linear equations for y. We're going to take that and put it all together to learn about systems of linear equations. So today we're going to focus on solving systems of linear equations by graphing. There's more than one way to solve, but today we will just focus on the graphing part. So you're going to go ahead and start at the front of your foldable to fill in some definitions. So the first thing we have is the definition for system of linear equations. So write down system of linear equations. This is a set of two or more linear equations in the same variables. So basically just meaning you have at least two linear equations that have the same variables. The second definition we have is a solution of a system of linear equations. This is an ordered pair that is a solution of each equation in the system. It is the point of intersection of the graphs of the equations. So in other words, if you were to find a point on the graph of the equation, this point will be a solution to both linear equations. Therefore, we call it a solution of the linear equations. So let's take a look at how we are going to do this. How are we going to find the solution? So here are your steps. Step number one, write down each step as I go through them. So step number one, solve each equation for y. We know that if we have our equations solved for y, we can graph them easily because we will know our y-intercept and our slope. They may give you the equations already solved for y and they may not. So if they're not, you'll go ahead and do that first. Step number two, graph each equation in the same coordinate plane. The key here is to graph them in the same coordinate plane so that we can see where their point of intersection is. That brings us to step number three, estimate the point of intersection. So look on your graph and see where the lines cross and approximate what point that is. And finally, step number four, check the point by substituting for x and y in each equation of the original system. We don't want to just rely on looking at the graph because sometimes we know that our lines may be a little crooked and it may not exactly be on the point. So we can estimate by looking at the graph, but then we want to check by actually substituting our point in. So let's take a look at an example. So you can go through this example on your paper. If you flip open your foldable, this is the example on the left-hand page as I go through it here. So example one, solve the system by graphing. So we have two linear equations, y equals 2x plus 5 and y plus 4x equals negative 1. Step one told us that we need to solve each equation for y. So our first equation is already solved for y equals 2x plus 5, but our second equation is not. So we want to solve y plus 4x equals 1 for y. So you can see here our first equation is already solved. Here our second one is not, so we will go ahead and take the steps to solve. Start by subtracting 4x on both sides to get y by itself, and that leaves us with y equals negative 4x minus 1. Now we have both of our equations solved for y. So here is equation number 1. Here is equation number 2. We're going to move on to step number 2 and graph those equations. So here we have our first equation. I'm going to use my y-intercept, which is 5, and my slope, which is 2, to graph this equation. So I'll start by plotting my y-intercept, which is 5. There we go. I will use my slope to find another point. Our slope is 2, so if we're considering the rise over run, our rise is 2 and our run is 1. So we will go up 2, go up 2, 1, 2, and our run is 1. So there's our second point. We can take a ruler and graph or draw a line through those 2 points to graph the equation. Here's equation number 2. Our y-intercept is negative 1, so I will plot a point at negative 1. Our slope is negative 4. That means our rise is negative 4 and our run is 1. So we will go down 4, 1, 2, 3, 4, and run 1, so go one place to the right. Again, connect those 2 points, and now we have graphed our linear equations. So now we'll take a look at that graph to estimate the point of intersection. So here's our graph again. If you look right here, this is where the 2 graphs intersect. It looks to be at the point -1, 3. So that's our estimate. Now we're going to plug that point into each equation to make sure that it is indeed correct. So our estimate was the point -1, 3, which we have here. So we're going to plug that into each equation to make sure that it is correct. So for equation number 1, y equals 2x plus 5, we're going to plug 3 in for y, -1 for x. So we have 3 equals 2 times -1 plus 5. That will simplify to 3 equals -2 plus 5 because 2 times -1 is -2. And that gives us 3 equals 3 because -2 plus 5 is equal to 3. So check. The solution worked in that equation. Let's check equation number 2. Y plus 4x equals -1. We substitute 3 in for y, -1 for x. So we have 3 plus -4 equals -1, and 3 plus -4 does equal -1. So check, that works as well. So we can conclude that the solution to the system of linear equations is the point -1, 3. So that completes example number 1. Let's move on and do the second example, which is a real-life application. So this is on the right-hand page of the inside of your foldable. So it says, a kicker on a football team scores 1 point for making an extra point. And let's just cover this so we can focus. Here we go. 1 point for making an extra point and 3 points for making a field goal. The kicker makes a total of 8 extra points and field goals in a game and scores 12 points. Write and solve a system of linear equations to find the number x of extra points and the number y of field goals. So when you have a real-life application, you need to write the 2 linear equations that you're going to use. So they're going to give you enough information to do that. So on your paper you have some boxes. We're going to use that to write a verbal model. The verbal model will help us write our equations. So your first 3 boxes, we're going to take the number of extra points. This is going to be represented by the variable x, and the number of field goals, which is represented by the variable y, and we know that if we add them together, that's going to give us our total number of kicks, because you're kicking for an extra point and you're kicking for field goals. Our second verbal model is going to be the points per extra point, so basically the number of points that you get for scoring a kick that earned you an extra point, times the number of extra points, x, plus the points per field goal times the number of field goals, y. And altogether, this is going to equal your total number of points. So this is actually the perfect example as the Super Bowl is approaching. So let's use our verbal models to now write our equations. So I'm going to plug in what I know about each equation. So the number of extra points is represented by the variable x. So I'm going to pull my x up. The number of field goals is represented by y. That's essentially what we're looking for. We're trying to figure out how many extra points and how many field goals. So we know that if we add them together, that's going to give us a total of 8, because it tells us in the problem that the player made a total of it says the kicker makes a total of 8 extra points and field goals. So that's how many kicks the player did, the total number of kicks. So the points per extra point is just 1 times the number of extra points, that's represented by x, plus the points per field goal. We know we get 3 points for a field goal times the number of field goals, which is y, and we know that altogether the player scored 12 points. Because it tells us right here in the problem that the player scores 12 points. So here are 2 equations. We can now solve that system of linear equations the same way we did in example 1. So here are our equations. X plus y equals 8. I dropped the 1 in front of the x because we know that 1x is the same as x. So x plus 3y equals 12. I need to rewrite my equations so that they are in terms of y. So I'm going to solve for y, subtract x on both sides. So we're left with y equals negative x plus 8. That is our first equation. Just put a little box around that. And our second equation, subtract x from both sides. We're trying to get y by itself. So then we have 3y equals negative x plus 12. Divide both sides by 3. Make sure that you not only divide the coefficient for x by 3, but you also divide the constant by 3. So you're left with y equals negative 1/3 x plus 4. Because this is technically a negative 1 divided by 3, just simplifies to negative 1/3. 12 divided by 3 is 4. So here's our second equation. Now we know both equations, we can go ahead and graph them. So here our y-intercept is 8. So let's plot 8. Our slope is negative 1, which means we're going to go down 1, that's our rise, and to the right 1, that's our run. So down 1 to the right 1, there's our 2 points. Draw the line. And in our second equation, our y-intercept is 4. And our slope is negative 1/3, so our rise is negative 1, our run is 3. So we will go down 1 and to the right 3. 1, 2, 3. Plot that point. Draw our line. And so we can now estimate the point of intersection. If you look here, it looks that the graphs of the equations are intersecting right at the point 6, 2. I'm going to just put a dot there to show that. So our x value is 6 and our y value is 2. So we can't be sure until we substitute in to check. So our estimate is 6, 2. Let's plug them into each equation. X plus y equals 8. Our x value is 6, y value is 2. Is 6 plus 2 equal to 8? Yes, it is. So it checks for the first equation. Let's do the second equation. X is 6, y is 2, so we have 6 plus 3 times 2 equals 12. 6 plus 6 equals 12. And yes, it works. So since it works for both equations, we can conclude that the solution is 6, 2. So the kicker made 6 extra points. This was our x value, the number of extra point kicks, and 2 field goals because y represented the field goals. So let's review how to solve a system of linear equations by graphing. When you're asked to solve a system of linear equations by graphing, you are looking for the point of intersection of the graphs of the equations. Our steps to do that are first solve each equation for y, graph each equation in the same coordinate plane, estimate the point of intersection, and finally check the point by substituting for x and y in each equation of the original system. Keep in mind when given a word problem, you have to write the equations. So if you set up a verbal model, that will help. If you missed anything, rewind the video, watch it again. When you come in tomorrow, we will do some practice problems and continue with some independent practice.